Please could you stop the noise? I'm trying to get some sleep from all the unborn chicken noises in my head. That's enough of Radiohead from the song Paranoid Android. Give it a listen, and then we will continue our journey. What we were up to? We were up to what to say? DDoS attack, the final section in which we are going to discuss some DNS stuff. What is DNS? How it actually works in the internet, and what are its implementations, etc. So I have started using a new plugin called what was it? What was it? Polonium, which is kind of tiling window manager but for KDE. So my workflow is slightly changed because as soon as I open the window, it automatically divides the window into half. Then if I open the Firefox, let's see where it will scale. Let it open, let it open. Okay. So here is my previous tabs. I have also started cloning this website using this video from the obviously Sharian's coding school. Sharian's coding school. Let me hide this. How can I hide this? Is there a way? Okay, I can hide it. So here it is, our OBS studio. And yes, this is the video that I am cloning into. And I have done, and this is the website that I started cloning. If you want to see my version, you can certainly do here. Let me run it. We have to navigate to our React folder. npm run dev.
फीचर का मैं इसका नाम रखना चाहता हूँ शोइंग शो कैनवस ठीक
Oh,
है
one
सेट
second.
शो
I have
कैनवस
to
ठीक है
stop
राइट
this,
तो अब
otherwise I will get a copyright claim. Okay, so here is my version of this website. I have created slide kind of. Yes. So this is my version. Implementation is not all completed, but I have completed till here. I just have to center the text. So if I try to center it, how can I do that? Text content, minimum height screen. And yes, now you can see the text. And if I just remove this background color, and yes, we have to align the text in between. We have to do a lot of stuff here, but this is the basic overview of the website that I am cloning. This video is what to say, I have to say in Hindi or in English. Wonderful गजब का वीडियो है जिसमें in this video we also learned how to actually scrap the web for the content. For example, the Shimla mirch, the capsicums, and the chilies that you've seen flying in the video, these are actually images, which is basically re-rendered, and the images are stored on this file, this data.js, which is itself a very large number of. Actually, the positioning of this image is stored in data.js, and actual image is stored where canvas images.js. These are actually array of links, so every image is being fetched by the internet from the same website. The website is this one. But this is not our purpose for this video. You have to watch that and you have to actually make the project in order to completely understand how React work and how this video stands out. So give it a thumbs up. Hey Sharians, if you're watching this, this is your thumbs up. You're indeed doing a great job. And let's navigate to our Cloudflare. I'm trying to get some sleep. Let's stop our server and navigate to where? Navigate to, we have to Cloudflare hash. Okay. And yes. Where we were? We were learning center. We were at learning center. We were talking about DDoS attack. The final chapter, the DNS. What is DNS? And let me zoom this also. Just for the sake that the video is clearly visible, I am just opening the, yes, the video is duly visible. Okay. So, what is DNS? The DNS stands for Domain Name System and is the phone book of internet human access information through domain names, like example newyorktimes.com, espn.com, or any website that you can say. And web browser interact through the IP address. The DNS translates the domain name to IP address, so browser can load internet resources. It is just like the phone book, as this article says. So you don't have to remember the phone number of every of your colleagues, if you every of your friend and family. You just have to remember their name. You can save their phone numbers with their name, tagged with their name in your phone book. So DNS do just like that. Each device connected to internet has a unique IP address, same like phone number. The DNS server eliminates the need of humans to memorize IP address such as 192.168.1.1 in IPv4 or more complex newer alphanumeric IP address. It is 128-bit IPv6 address. For example, 2400 double colon CB 00 colon 2048 colon 1 double colon C629. You get the idea. How does DNS work? The process of DNS resolution involves converting a host name, for example www.example.com, into a computer-friendly IP address such as 192.168.1.1. Okay, and do you know, guys, that it is easier to pronounce World Wide Web instead of www? It was a meme that I found it somewhere in the internet. Next, an IP address is given to each device on the internet, and the address is necessary to find the appropriate internet device. Like a street address is used to find a particular home. When a user wants to load a web page, a translation must occur between a user type and the web browser and machine friendly address necessary to locate the example.com web page. So basically, DNS is a translation layer. It translates the computer understandable, this digital for digit form of address, and between the human readable, this letter form of address. Okay. So in order to understand the process behind the DNS resolution, it's important to understand the different hardware components a DNS query must pass between. For the web browser, the DNS lookup behind the scenes requires no interaction from the user computer apart from initial request. Now we have some core DNS server involved in loading a web page. First is DNS recursor. The recursor can be thought as a librarian who is asked to go find a particular book somewhere in the library. The recursor is a server designed to receive queries from client machine through applications such as web browsers. Typically, the recursor is the responsible for making additional requests in order to satisfy the client DNS query. So this is something very important because I never in my life heard about this term DNS recursor. So I have to copy it and paste it just for the future reference. The DNS recursor is a server designed to receive queries from the client machine uh, through applications such as web browser. Okay. Next is root name server. The root server is the first step in translating or resolving human readable hostname into IP address. It can be thought of like an index in library, and that points to different rack of book. Okay. First step is the root server. You have to copy that also. First is recursion. Next, TLD name server. The top level domain server, TLD, can be thought of as specific rack of books in library. This name server is the next step in search for a specific IP address. It hosts the last portion of host name. For example, example.com, the TLD server is com. So basically com lists all the website registered within the com thing. And what root server is it? Okay. Next, authoritative name server. Okay, TLD specific rack of book. No, no, no. I just have to copy this part. In example.com, let me highlight it. The TLD server is com. Okay. The authoritative name server. The final name server can be thought of a dictionary on the rack of book in which a specific name can be translated into definition. The authoritative name server is the last stop. If an authoritative name server has access to the requested, it will return the IP address for the requested hostname back to the DNS recursor. Okay, so the first I have to actually double hash DNS. The DNS recursor is a server designed to receive query from client machine through applications such as browser. Okay. Then the query goes to root server, which is steps in translating human readable hostname into IP addresses. Then it goes to TLD server, top level domain server, and from there the actual IP address is being fetched. Okay. What's the difference between authoritative DNS server and a recursive DNS resolver? Okay. Both concepts refer to the server group of servers that are integral to DNS infrastructure, but each perform a different role and lives in different location inside the pipeline of a DNS query. One way to think about difference is recursive resolver is the beginning of the DNS query and the authoritative name server is at the end. So both are basically the host servers, a group of servers. Okay. And the recursive DNS resolver is the computer that responds to recursive requests from a client and takes the time to track down the DNS record. It does this by making a series of requests until it reaches the authoritative DNS name server for the request record, or times out or return an error if no record is found. Luckily, the recursive DNS resolver do not always need to make multiple requests in order to track down the records needed to respond to a client. Caching is a data persistent process that helps to short circuit the unnecessary request by serving the requested resource uh, recorded earlier in the DNS lookup. Authoritative DNS server. Put simply, an authoritative DNS server is a server that actually holds and responsible for DNS record resources. This is the server at the bottom of DNS lookup chain that will respond to the queried resource record, ultimately allowing the web browser making the request to reach the IP addresses needed to access the website or other web resources. An authoritative name server can satisfy query from its own data without needing to query another source. It is the final source of truth for certain DNS record. Okay. It's worth mentioning that in instances where the query is for a subdomain, for example, such as foo.example.com or blog.cloudflare.com, an additional name server will be added to the sequence after the authoritative name server, which is responsible for storing the subdomain CNAME record. If I remember, there is something called CNAME where 4 times A and A name, and these are something that found in DNS study. I don't know what was it, but we will see that. There's a difference between many DNS service and one that Cloudflare provides. The different DNS recursive resolvers such as Google DNS, OpenDNS providers like Comcast all maintain data center installations of DNS recursive resolver. These resolver allow for quick and easy query through optimized clusters of DNS optimized computer system. But they are fundamentally different than the name server hosted by Cloudflare. Cloudflare maintains infrastructure level name servers that are integral to the functioning of internet. One key example is F-root server network, which Cloudflare is partially responsible for hosting. The F-root is one of the root level DNS name server infrastructure component responsible for billion of internet requests per day. Our Anycast network put us in a unique position to handle large volume of DNS traffic without service interruption. Okay. And what are the steps in DNS lookup? For most situation, the DNS is concerned with the domain name being translated into appropriate IP address. To learn this process, it helps to follow the path of a DNS lookup as it travels from a web browser through the DNS lookup process and back again. Let's look at these steps. Note, Often, DNS lookup information will be cached either locally inside the querying computer or remotely stored in DNS infrastructure. There are typically 8 steps in DNS lookup. Okay, so these are the 4 steps and now there's 8 step. When DNS information is cached, steps are skipped from the DNS lookup process, which makes it quicker. The example below outlines the all 8 steps. When nothing is cached. Okay. So the first step is I type example.com into a web browser and the query travels into internet and received by a DNS recursive resolver. This guy. Okay. Next, the resolver then queries the root name server. This guy. And the root server then responds to the resolver with the TLD, top level domain, and DNS server such as .com or .net. We have typed the example .com, so it will the TLD server to the com. Okay, which stores the information for its domain. When searching for the example.com, our request is pointed toward .com TLD. Okay, and the resolver then make a request to .com TLD. Okay, the TLD responds with the IP address of the domain name server example.com. Lastly, the recursive resolver sends a query to domain's name server, which is this one. And what happened after that? The IP address for example is returned to the resolver from the name server, this guy. And the DNS resolver then responds to web browser with IP address of the domain requested initially. I think I should do something. What is it? Annotation. Let's see if the annotation still works or not. Yes. So we have something called first thing, the user, the web browser. Then the second thing, the name server. Oh, sorry, root name server. So the second thing would be root, R for root, and N for name server. We have third thing called the TLD. Third step, TLD. With then we have fourth step, the make a request to .com TLD, then IP address of the domain name server, and return to the resolver for the name server. Okay, one second. Root name server. Then we have one second. We have TLD, and then we have the final name server. What was it? I have to actually. Then I have to remove this all. Okay. Yes. So actually I forgot the thing. Okay. So we have recursor. Okay. Now. Sorry for the delay. Now I will draw on this. So the first priority is given to one second. Let me move this. How can I move this? Mm-hmm. Yes. So the first thing is we have DNS recursor. Okay. Second step is we have root server. Then third is we have a TLD server. And the fourth step we have the authoritative name server. Okay. So the we have equation. So we have also a zero index. We have user. So the user actually passes a request. So request goes to DNS recursor. Okay. This is our the first step. Then resolver queries the root name server. Then the request forwarded to this one. Okay. The resolver then makes a request to .com TLD. The third thing happens to this one. And then the resolver makes a request to .com TLD. The TLD server responds. One second. The root server then responds to resolver with the address of TLD and the DNS server, which stores the information for its domain. When searching, for example, our resources pointed towards the .com TLD. Okay. And the resolver then make a request to .com TLD. Okay. it actually is pointing out. So I have to say that the request is being pointed. For example, if I choose some different color, okay, and the request is just being pointed to the third party, then actually the first party takes the initiative to connect with the uh, third one. So this is our fourth request directly. Okay, I'm very sorry. We have to select this. I am doing nothing good. What should I do? A4. One second. I do have a A4 sheet. Always open, always ready. If I make you understand from this article, so we have a user, we have a recursor, then we have a TLD server, and finally we have authoritative name server. NS for name server. Okay. But we have user, recursor, TLD server. Actually, I missed one party, which is root server. So I would write it here, root server. So user sends a query. The query is being received by recursor. Okay. Then recursor send it to root server. Root server basically simply points out the TLD server. Then recursor has to connect with TLD server. So this is our first step. This is the second step. This is the third step, basically pointing out. Then this is the fourth step. Okay. And what will TLD server will do? The TLD server then responds with the IP address of the domain name server. Okay. The TLD server also does the response. So again, the TLD server, let me do that. The TLD server basically point out this party. Okay, then it's his own responsibility to connect with then the recursor has to so okay, so I have to actually write the fourth and fifth step. Then sixth step is to recursor has to connect with the authoritative name server as the sixth step. And what was the seventh step then? The IP address, for example, return to the resolver from the name server, or return to the resolver from the name server. Okay, resolver to the name server. Resolver to who was the resolver here? The resolver then makes a request to .com TLD. Okay, who is the resolver? The resolver then queries to the DNS. Okay, so the recursor is also known as resolver. The recursive resolver sends a query to the and then it is returned from the name server, and the DNS resolver then respond to web browser. Okay, okay, okay. Now I got it. So the seventh step is actually the address is being sent back to the recursor, which is the seventh step, and final step. This is sent back to the user, the eighth step. And I think this is how this thing looks. Then how I will pause this? I have to delete this. Okay. Actually, there's no erase button here. God knows. But I think you get the idea for this. So let me refresh the page. Don't save. Yes. And then we have two more steps. The browser make the HTTP request to the IP address, and the server at the IP returns the web page to be rendered in browser. So yes, we do have an example here. We have a resolver which is asked to root server. Root server then sends something to resolver. Then it asks TLD server. It then gives it some answer. Then it asks for something. example.com and the resolver. Okay, recursive query, iterative query. But what is difference between recursive query and iterative query? Our beloved chat GPT, where are you when in time of need? What is recursive? What is recursive and iterative? DNS. Let me zoom it so you guys can also see. In the context of DNS, recursive and iterative queries refers to different ways in which DNS resolver, the client, obtain answers from the domain name lookup. They describe how DNS system work to resolve domain name into IP addresses or vice versa. Recursive query. The recursive query is the one where the DNS resolver, typically your local DNS server or the one provided by ISP, is responsible for doing all the work or heavy lifting to resolve the query. It will take the full responsibility of the following the chain of DNS record, contacting multiple DNS server if necessary. How it works? The client sends the recursive DNS query to the resolver. Okay. And if the DNS resolver does not have the requested resource cache, it will query the DNS hierarchy, starting with the root DNS server, then contacting the appropriate top level domain, then querying the authoritative DNS server for the domain in question. Once the resolver finds the answer, it returns the final result IP address to the client. The key feature here is that the DNS resolver performs the entire process of resolving the domain name, and the client only receives the final answer, either the IP address or an error, and domain cannot be resolved. If domain cannot be resolved. The same example, if you type the example.com in your web browser, your computer asks a recursive DNS server to resolve the address. The recursive DNS server will do the entire lookup process and provide you browser with the IP address of this. An iterative query in which DNS resolver does not do all work of the chain of DNS server. Instead, it queries the DNS server for the best possible answer at that level. If the server cannot provide direct answer, it returns a referral to another DNS server higher up in the hierarchy, and the client queries that server. Okay. In this case, the client must continue querying the DNS server at each step of the hierarchy until it reaches the authoritative DNS server and can provide the answer. For example, if you type a website name in browser, it sends an iterative query to the DNS resolver. The resolver does not know the answer. It might return a .com TLD server. Your computer will then send a query to TLD server, which might refer to it authoritative server for example.com. The client then queries to authoritative server, which returns the final IP address. And we have recursive query. The DNS resolver take full responsibility for resolving the DNS query, providing the final answer. And in an iterative query, the client or the DNS resolver is responsible for querying the appropriate server at each level of the DNS hierarchy until the final answer is obtained. I have to copy this. This is a golden thing. Next, process. The DNS server does all the work of finding the correct IP address and return it to client. Iterative, the DNS provide referrals and expects the client to continue the process by querying the referred server. Load. Recursive query, more load on DNS server because it handles the entire process. And just let's read the use cases. Recursive queries are often used by end user devices like computer and smartphone, which are looking for the final answer to a domain name lookup. Iterative queries are the commonly used by DNS server when they need to find out where direct request or particular domain when name DNS server are forwarding queries to other servers in DNS hierarchy. Okay, now I got it. Next, DNS resolver is the first stop in the DNS lookup, and it is responsible for dealing with client that made initial request. Where it was initial request The resolver starts the sequence of query that ultimately leads to URL being translated into necessary IP address. Typical uncached DNS lookup will involve both recursive and iterative query. It's important to differentiate between a recursive DNS query and the recursive DNS resolver. A query refers to the request, and a resolver is requiring the resolution of the request. The DNS recursive resolver is the computer that accepts the recursive query and processes the information by making the necessary request. Okay. And we have three types of query. Okay. Then first is recursive, then we have iterative, and then there is non-recursive. Okay. In the recursive query, a DNS client requires that a DNS server, typically a DNS recursive resolver, will respond to a client with either the requested resource or an error message. Okay. Then we have iterative query. In this situation, the client will allow a DNS server to return the best answer it can. So answer can vary. It will answer that you have to ask that person, or you have to ask that server, not this server. Then the client device himself had to do the work in order to find the IP address. Then we have non-recursive query, and typically this will occur when a DNS resolver client queries to a DNS server for a record that it has access to, either because it's authoritative for a record or a record to exist inside of its cache. Typically, a DNS server will cache DNS record to prevent additional bandwidth consumption or to load upstream server. Okay. One second. Then what is non-recursive? This is a new thing. I also heard that there is what non-recursive query 2. Is it same as iterative? Yes, a non-recursive query is similar to an iterative query in many contexts and are used interchangeably, but there are subtle difference in how terms are applied during the situation. For example, a non-recursive query refers to type of query when DNS resolver does not perform any further query on behalf of the client. It does not have answer. It will provide the answer directly or return a referral to another DNS server, which also the iterative query do, and that is a high level DNS server in hierarchy. The client DNS resolver is expected to continue the query process from the point onward. The difference between non-recursive and iterative query: the non-recursive query refers to a query made by the DNS resolver and does not attempt to resolve the query fully, but either returns an answer if it has cached result or provides a referral to the next server in the hierarchy. It is often seen in the query that a DNS server receives from one server, a client, when DNS server directly. And okay, oh, one second, let me read it again. The non-recursive query refers to a query made by a DNS resolver that does not attempt to resolve the query fully, but either returns an answer if it has cached result or provide a referral to the next server. This is often seen in the query that a DNS server receives from the other server when a client queries a DNS server directly. Iterative query generally refers to the query process itself. Okay. Where a resolver or client is receiving answer, usually referrals from the server, and must continue querying the high level server until it's get a direct answer. In practical uses, the non-recursive and iterative queries are often used in same context because in both cases, the DNS server typically only provides a referral or partial answer, leaving the client or next DNS server to continue the resolution. A query made by client to where the server does not attempt full resolution. In the query, the server receives referral. Okay. In practice, a non-recursive query to a DNS server might result in an iterative process if the server provides a referral and the client or resolver follow-ups with further queries. Therefore, in many contexts, both terms can overlap but might be distinguished based on whether you are focusing on the behavior of the querying entity or the query resolution process. Okay. So these two are what to say query resolution process, yeah, or behavior, iterative, recursive, and then we have non-recursive. Recursive. I have to copy it and make these necessary changes. The DNS resolver uh, responds with the uh, referral and does not provide the final answer to the client. We have query resolution process. So we have iterative query. If there are two query resolution process, recursive and non-recursive, then there must be two, okay, resolution behavior, then there must be two resolution process, iterative and other one iterative and recursive. Okay, okay, okay. Resolution, and we have iterative resolution, and we have to write the same thing. Okay, same thing here and here. The just we have to keep it short. The DNS resolver, let copy a point from here. The resolver does not send queries to another DNS server from the root DNS of working with on the have to send queries to another. Send queries to another DNS server starting from the root DNS server and working its way down through DLD. Oh. Next, characteristic. The recursive resolver is fully responsible for the resolving the domain name query. Client typically just wait for the result. Okay. This is seen when the clients send queries to the local DNS resolver. Okay. Okay, never mind, never mind, never mind. We will continue to our DNS. What is DNS caching? The purpose of DNS caching is to temporarily store data in a location that results in improvements in performance and reliability for reliability for data request. Caching involves storing data closer to the requesting client. So DNS query can be resolved earlier, or additional queries further down the DNS lookup chain can be avoided, thereby improving the load times and reduce bandwidth and CPU consumption. The DNS data can be cached in variety of location, each of which will store DNS record for a set amount of time determined by the time to live (TTL). Browser DNS cache. Modern web browsers are designed by default to cache DNS record for the set amount of time. The process is obvious. The closer the DNS caching occurs to the browser, fewer the processing steps. When a request is made from a DNS record, the browser caches first location checked for the requested. In Chrome, you can see the status of DNS cache by going to Chrome net internal/DNS. Let's check it for my browser. I don't have Chrome, but I have Chromium. Let it open, and they have to paste the URL. And yes, input a domain name to look up. Okay, so it does not directly gives it. For example, if I see youtube.com, look up. The resolve IP address of YouTube is this. No alternative endpoint. Okay, good. Next, we have operating system level DNS caching. So the operating system DNS resolver is second and the last local stop before a DNS query leaves your machine. The process inside of your operating system that is designed to handle query is called a stub resolver or DNS client. When the stub resolver gets a request from the application, it first checks its own cache to see if it has record. If does not, it sends a DNS query with a recursive flag set outside local network inside the ISP. Okay. And yes, the A record, ANS record, and 4A records, they have to study. When the recursive resolver inside the ISP receives a DNS query, like all the previous step, it will also check if the request host to host IP address translation is already inside a local persistence layer. The recursive resolver has additional functionality depending on the type of records it has in cache. If the resolver does not have a record, but it does have the NS record for the authoritative name server, it will query those name server directly, bypassing several steps in the DNS query. This shortcut prevents lookup from the root and the .com name server. In our search, for example .com, the help resolution of DNS server or DNS query occurs more quickly. If the resolver does not have the NS record, it will then send a query to TLD server, skipping the root server. It is the unlikely event that the resolver does not have records pointing to the TLD server. It will then query the root server. This event typically occurs after the DNS has been parsed. Okay, but why the root server is? But I have heard that the root server comes. Let ask the Chat GPT. If the root, if the querying the root server is the first step, then why आखिर क्यों? Then why the article mentioned the TLD server is it first? Okay, so we are talking about optimization. The key here idea is that the DNS resolution can take more efficient path depending on what records the resolver already has. Here's a breakdown why TLD server might be queried first and how it's related to root server. First, caching and optimization. The DNS resolver cached record to avoid repetitive query. If the resolver already has a name server record, NS record, for the authoritative name server of a domain, such as name server for example.com, it can directly query those authoritative name server without the needing to go through the root server or the TLD server. Okay. And in this case, the resolver can bypass the root and TLD server because it already know the name server possible responsible for the domain via NS record. This optimize the process and reduce the number of queries. Then when the NS records are missing, if the resolver does not have the NS record in its cache, it will then need to find them. To do so, it will first query the TLD server because the TLD server knows how or which authoritative name server are responsible for the domain within that TLD. The TLD server will respond with NS record for the domain. Once the resolver has the NS record, it can query both authoritative name server and the actual A record. Okay. Okay. So, if we are going from starting from 1 to 4, then the second next best step is querying the TLD server because we do have a relation with authoritative name server already. So, we query to the TLD server directly. Okay, next, root server query. In rare cases that the resolver does not have information which TLD server are responsible for the particular domain, it will query the root server. The root server do not store domain specific information, but can they directly direct the resolver to appropriate TLD server like .com or .org. Most of the time, DNS resolver will already know which TLD server a query either to the previous lookup, but then do not need to go all way back to the root. If the resolver has the NS record, it can directly query. If the resolver does not have the NS record, it will take a step back and talk to TLD server. And if it does not know the TLD server, then it will ask to root server. Okay. And we have finished the only single article this time, the article about DNS. And I think this was a good read. This was a good thing to cover. Okay. And it's already around 7:47 and I do have to go office. So I have to finish this stream early. I am very sorry, but we will keep coming and keep completing the DNS or DDoS section as full. Okay, so we have transitioned into a DNS section from the DDoS section. Then we have some famous DDoS attacks. Okay. I think this should not be taken. Then we have HTTP section, ICMP section, IoT section, etc. I think the DDoS section has been successfully finished by us, and from this video, the DNS section is being started. So let's again visit the learning center again, okay, and see. Let's see where is our DNS section located. We have directly jumped to this section, DNS section. We skipped the CDN section. Okay, then from right now on, we will finish this DNS section. We have already covered a single article, what is DNS. Then we will, from next video, we will cover the 1111 DNS record, securing DNS, domain registration. Then we will come to DNS glossary. And after that, we will cover the CDN section. Okay, guys. So that's all for this video. Thank you for joining me in and see you in the next one.